Hi, welcome to the Shiko Math Lab. And in this lecture series, we're going to talk about the polar coordinates and its role play in the calculus here. We're going to have several parts in this lecture series. The first part, we just start with the basic. We're going to do is the introduction for the polar coordinates and some of the key characteristics about the polar coordinates here. Okay, let's go ahead. Let's get a start. Okay. Since we were in the elementary school, all the coordinates system we learn is we call it the Cartesian. Cartesian coordinates. Some people also call it is the rectangular coordinates. This is the typical one. We learned when we were young, like here we have the x and the y's here, right? So we have x and the y. And then for any points, like if you have any points in the plane. So for example, here, this is the plane. For the point, we can always represent this point for the x and the y's here. So this is the coordinate plane we are very familiar with. So we call this a Cartesian. So now we're going to talk about another coordinates plane. We call this the polar. In fact, in the calculus, like the 1, 2, 3, your calculus career, you're going to dealing with another two coordinates. So one is we call it the cylindrical, and the other we call it the spherical coordinates. So polar, this is another one we're going to get familiar with. So what is the polar coordinates here? All right, so for the polar coordinates here, so basically the way is, so for any points, right? So for any points in the, in the plane here, then the way we represent that point is what? Instead of x, y, we represent is r thetas here. So what is the r? So for example, this is my point, right? So this is my point P. So the polar coordinates they're going to have, we call this the polar axis here. So this polar axis, basically, we use kind of similar like the positive x-axis for that. And then we have angles here. So this angle, this is my angles here. So this is my angle, right? So if you go in the counterclockwise, then this angle is positive. If you go the clockwise, it's negative, right? So the theta, we say if you go counterclockwise, then the angle we treat as a positive angle. If you go clockwise, then this angle we will treat as the negatives here. And then this is the here with, in the Cartesian, we call this one, we call this what? Origins, right? So where is the origin is 0, 0. So in the polar, this is what we call is the pole. Okay, so where it starts here. This is what we call is the polar coordinates here. All right. So before I'm filling up what is the generalized form for the polar point. And let's try to take a look at the example and get familiar with it. Then we'll go back here to write down the general forms here. Okay, so now here problems here, I have 4 different points in the polar coordinates. So let's get familiar with how do I represent the points here. So, okay, so remember here, right? So remember here, okay? So the positive axis is what? Is the polar axis here, right? So now let's get rid of this here. All right, so in here, I better not put it here. Maybe let's just put the polar axis here. Okay, so for the polar axis here, this is my polar axis. Now my angle is 5 pi over 4. 5 pi over 4, it is a little bit bigger than pi, right? So the 5 pi over 4 will go to here. So from here to here, this is the angle is 5 pi over 4 because we are swing the counterclockwise. And what is the ones here? One is this distance. Okay, this distance is 1. So this point here, so that's why this point is 1 and the 5 pi over 4. Okay, so if you superimpose xy coordinates, so this is kind of like on the third quadrant, right? Okay, now let's take a look at the second ones here, right? This is the part A, this is the part B here. So here, let's see here, this is my polar axis here. I start here. And now I'm going to swim. So 3 pi. So how do I get the 3 pi here, right? So here, take a look here. If you go the whole circle is 2 pi. So I will go the here is 3 pi, right? And then after I swim to the 3 pi, then this green one, right? So the length of this green one, and make sure this is my pole, right? So the length of this green one is what? Length of this green one is 2. Okay, that is how this point at here, we can say this is 2 and 3 pi. Okay, now let's take a look the next ones here. The next one, this is part C. This is negative 2 pi over 3. So here, let's do the same thing. This is my polar axis here. Now I am going to swim because this is negative, right? So I'm going to swing counterclockwise. So the 2 pi over 3 is about like 120 degrees. So it's a little bit bigger. And so I'm going to go, I'm going to go here. Right, so I'm going to start at here. So this is 2 pi over 3, but because it is swing counterclockwise, clockwise, so I thought it's positive. Then where is 2 here? So here, this, all right, so this green line is here, right? So this green line is 2. So that's why the 2 is the length, right? So this green line is 2. So that's why this points here, what I can say, this is the 2 negative 2 pi over 3 here. All right, okay, so now let's take a look at this, the last one here. Okay, the last one. Okay, so I'm doing, let's put a polar axis here. Okay, I'm going to swing the 3 pi over 4. So the 3 pi over 4 is kind of like in the middle of the here. Oh, I should use use the pink color. So this is a 3 pi over 4. It's a counterclockwise, right? So this is 3 pi over 4. Okay, so the 3 pi over 4, and then okay, so I'm going to have the negative 3. Okay, so here, let's take a look here. I'm going to use the different colors here. So 3 pi over 4, if, okay, so for this gold ones here, the length of this gold one is 3, right? So I know this point here, at the end of this gold ones here, this point will be 3, the 3 pi over 4. But that is not what we are looking for, because we are looking for the negative. So the negative, that means you go to the opposite directions here. So it's this green one is a totally opposite direction, and the length of this green one is what is -3, right? So this is the opposite direction for this. So that's why this point here. So this is the point I can say this one is what? This is -3 and 3 pi over 4. All right. So as you can see, there are so many different ways. So for example, this is -3. So this green one is here. This is the point, -3, 3 pi over 4. I can also represent this point. Let me choose a different color. I can also represent this point. Let's see here, blue one. I can say, hey, I'm a swing this way, right? So this blue one, so this blue one will be negative what? Pi over 4 here, right? So this same point, if I swim the negative pi over 4, then this length will be 3. So I can also use 3 and then negative pi over 4 here. Right, so that's pretty cool, right? Also, the same way I can do like this, okay? So take a look here. Let me see here. Let me use, okay, so this color here. I can say here, I can swing all the way from here, add a pi here, right? So this green one, so what is this green one? So this angle's here, right? So this angle I total swing, how much here is 3 pi over 4, right? And then plus pi, right? So this one's here, I swing the 7 pi, right? So this is the plus pi's here. So this one I swing the 7 pi over 4 here, right? So I can swing it all the way to here. Then if I do this, then my length will be positive. So the same point here, I can represent as the 7 pi over 4 here, right? So that's why the polar point is not unique. So if you swim, so the opposite one will give you the negative r's here. Okay, so now let's take a look at this ones here, right? So the first one's here, name, I'm going to go back to write down my general formulas here. Okay, this point is 5 pi over 4 to the 1. Okay, look here. I can do this one. I can say here, all right? So this one's here, I can say, okay, I will go swing, the whole circle. Then go to the 5 pi over 4. So this will give me exactly the same point, the golden ones here, right? So still is 1. But right now, instead of the 5 pi over 4, so it's 5 pi over 4 plus 2 pi. Correct? Right? So it's 5 pi over 4 plus 2 pi. Or, in fact, I can generalize it. I can say I can swim many, many circles, right? So that's why I can say it's 5 pi over 4 plus what? Plus 2n pi here, right? Plus 2n pi. So I can swim many, many circles. Then as soon as I stop at here, then I have the same point. Or is another way I can do this. I can use negatives here, right? So because here, let's try to see here. All right, so here, so this is the, let me give a better color. You can see here, okay. So this is red color, okay. So this is the opposite, this green colors here. Okay, so how can I get here, right? So I can do, take a look here. I can do this. I can do the whole circles, the 5 pi over 4. Then I can add just 1 pi here, right? So 1 pi, so in here, but if I stop here, right? So for this point will be 1 then this is a 5 pi over 4 plus just pi, right? I know from the example number 4, I can add what? I can add a negative sign in front of the 1. So if I add a negative sign, then boom, bump back to here. So it will be negative 1, 5 pi over 4 plus pi, right? So now I can do this many, many times. So like we said, as long as I add the odd number of the pi's, I can always back to this point, right? So these two are in fact is the same point. So now I can generalize that. I can say instead of 2n pi, I can say as long as I do 2n plus 1 pi, then I add what? I add negative numbers, right? So I will be give me the same points here. So now let's go back to here. So that's why in here I want to write a very useful formula. So the point r theta, right? So for any points r theta, you can this point you can rewrite it as r. Then the theta could be any theta plus 2n pi. That means you can turn many, many circles here, right? So it will give you the same things here. Or we said you can add a negative to the front. Then instead of do the 2n pi, you will just do theta plus 2n plus 1 pi. That means you add 1 extra pi layer. So just like for this ones here, what you can do is here, you can say, right? So you can say I'm doing here, I'm going to do, right? The whole thing's the whole pi, then I'm going to stop here. Then here, this will be your, so if you stop here, this is the point, will be the positive R. So you put the negative R, go boom, go back to here. All right, so that is the two things we learned from here. All right, so now let's take a look at the next ones here. So we want to see the relation between the polar and the Cartesian. So we said, for the polar and the Cartesians, right? So if you see x and y, then this is the rectangular. So any points here you can represent of the x, y's here. Also, if you take a look at this ones here, right? So this is the, this is your, this is your polars, right? So that's why any points there you can write as what? R theta here. So I want to find the relation. So in fact, relation is pretty simple here. That's why if you give me the Cartesian, if you give me the polars here, I can find the xy, because you see here, this is the x's, right? This is the y. So r is what? R is the hypotenuse here. So I know we know the cosine theta is equal to what? Adjacent over hypotenuse. That is how do I get x equal to the r cosine theta. So the same way is here, we say the sine theta is equal to the opposite. So it's y over r. So that's why I can say y is equal to what? The r sine theta, right? So the same way for the Cartesian to the polar, you can say here the same things here. So we know by the Pythagorean, right? So this is a Pythagorean theory, x squared plus y squared equal to r squared. So that's why r, you can just square roots of that. Then this is also, we use the tangent. Tangent is opposite over adjacent. So that's why the tangent theta equal to the y over x. So you can find the tangent, you can find the theta, you just do a arctan y over x, right? And then the r, you can just take the square roots, right? So r will just be the positive and negative square roots of x squared plus y squared. But be very careful, right? So we need to know is r is a positive or negative, and which, what is the theta is which quadrant it is, right? Okay, let's take a look at some examples here. Okay, so now in here, the first thing here, they said, hey, plot the polar, and then find the Cartesians here. All right, so let's see here. So find the polar, and then find the Cartesians here. All right, so let's do this. Let's put the both polar and the Cartesian at the same place. So it's 4 pi over 3. 4 pi over 3, so it's here. So you swing 4 pi over 3, that's right? So that is about 240 degrees. So here, okay, so then in here you are, right? So your R is here, right? So this is R. And so R is 4, right? So this is 4. And this angle is 4 pi over 3. Okay, so now I need to find the x coordinates and the y coordinates, right? So x is R cosine 4 pi over 3. R is 4, right? So cosine 4 pi over 3. So it's cosine 240 degrees. So this will be 4 times negative 1/2 is 2. Negative 2, right? All right. Then y is equal to the r sine theta. So 4 pi over 3. Then this is 4 times the negative square root of the 3 over 2. So it's negative 2 square root of the 3. So I know I can change this coordinate to the negative 2 square root of the 3. Hey, it makes sense, right? So why this is in the quadrant number what? Number 3 is here. So we know we did it right. Okay, now let's take a look at this one. All right, so here, let's be careful here, right? So this is a 3 pi over 4 here, right? Okay, 3 pi over 4. So it will be here. Okay, so let's start to swim. So 3 pi over 4. So it's a swim to here. All right, so this is 3 pi over 4 because it's a positive. So I swing the, counterclockwise. And then here, all right, then if I stop here, then this will be 2, right? But then it asks us for the negative 2. So where is my point going to go? My point going to go to where? The opposite here, right? So this will be my point. So I expect my x should be positive, and then my y should be negative. So let's see here, x is equal to the negative 2 cosine 3 pi over 4. All right, cosine 3 pi over 4, so this is negative 2 times the negative square root of the 2 over 2. I do have a positive, right? Square root of 2, that's good. And the y is equal to r, so it's a negative 2 sine 3 pi over 2. So then this will be negative what? Square root of the 2 over 2. So you need to remember your unit circles, right? So this is negative square root of 2. So that means this point corresponding to the square root of the 2 and the negative square root of the 2. And we know it's on the fourth quadrant, so it is the truth here. Okay, so now let's take a look at this ones here, all right? So here, need to be very careful, right? Okay, so here. All right, so here, let's see here. Okay, so this one is a negative pi over 3. Negative pi over 3, so I know I need to swim clockwise, so I swim to here. Okay, I swim to here, and then I have a r. If r here is 3, so this point here, you swim here, you stop here, and then this is r, right? So this is 3. But I have a negative 3, so what I need to do? I need to go backward, right? So here, totally go back here. So this is the point I expect to be. So then this one will become negative 3 here. So I expect the x to be negative, y be positive. So let's see the x equal to negative 3 cosine negative pi over 3 here, right? So the negative pi over 3 is 1/2. So this is a negative 3/2. Then the y is negative 3 sine negative pi over 3. So this one's here will give it the negative 3, negative square root of the 3 over 2. All right, so this will give me positive 3 square root of the 3 over 2. All right, so I know this point is here corresponding to negative 3/2 and 3 square roots of the 3 over 2. And is on the second quadrant as we expected. So that is correct. All right, so this is how do we change from polar to the Cartesians here. Okay, now let's take a look. So we want to change it to the Cartesian. So this one, they give you a little bit of kind of the things, the trick here. They said, I want to find the two polar coordinates, one with r greater than 0, one with r less than 0. Okay, so let's see here. All right. Okay, so now in here, first, let's take a look. Where is this? So x equal to the square root of the 3 and y equal to negative 1. So this is my point, right? This is square root of the 3, negative 1. Okay, so now, first, r is easy. So r is square roots of the square root of the 3 square plus negative 1 square. So r is equal to 2. All right, so r equal to 2. Then the tangent theta is y over, so it's negative square root of the 3 here, right? So now I can get the arctangent, so the theta equal to the arctan negative 1 square root of the 3 here, right? So we know the negative 1/3 is what? Is negative pi over 6. All right, so it's negative pi over 6 here. Okay, so now in here, okay, so here is a pi over 6. So I know that this point here, so what can I do here? So I can, okay, so here, right? So if you swim like this way, okay, so if you swim, you say, hey, it's negative. Can I swim like this? Okay, so if you swim like this, right? So if you swim like this, what happens here? This is the negative because your point is negative pi over 6. So this point you can write as 2 negative pi over 6. But this is not what the problem wants. The problem say, hey, I want my angle is positive. Okay, so if you want your angle is positive, so let's think here, what can I do here? I said, okay, I can do this one, right? So I can swing the positive, I can go swing to here, because I know if I go the backward here, right? So that if I go the backward here, if I go flip, so this point will be negative 2. And so in here, you swim to here and stop, right? So you're going to have what? So what is this one's here? So this red one will be what? Will be 5 pi over 6, correct? Then you stopped, right? And so what is the, so this is a 5 pi over 6, but this is the point, right? So this is a 2 here, right? So you do a negative. So that's why first point I have here, we can find is negative 2, 5 pi over 6. So remember here, if we swing to here, this is the opposite. So if it's 2, then this one will be negative 2. So this is 1 point, I can do that. Now let's take a look at another ones here. So the another ones here, I can do, because they want the positives, right? what I can do here, let's see, give a different colors here. Okay, so I can swim. Okay, so this color is not very strong. Okay, so here I can swim. I made put a purple, maybe it's better. I can swim all the way to here. Right, so I start all the way to here, right? So from the positive, so I have a positive angle, I have a swim all the way to here. So what is this purple angles here? The purple angle will be 11 pi over 6, right? Because it's a stop at this terminal line. Do I need to change to negative? No, it's positive, right? So this will be 2 and 11 pi over 6. Right, so I got the 2 points, one with a positive r, one with a negative r, and all the angles are within the setup, the 2 pi. Okay, now let's take a look at the other ones here. This one's here. This one, this is -6 and 0. -6 and 0. So here is my point. This is -6 and 0. All right, so I know the r's here will just be the -6 square plus 0 square, so it's 6 here. Okay, so now let's think here. If I swim here, all right, so the first one's here, I swim like this way. Okay, I can go from here, because they want a positive angle, I can go here. All right, so if I stop in here, right? So if I stop in here, so what is this point I stop in here? This will be the pi, right? And because the terminal point is where I stop, so this point I can rewrite as what? 6 and the pi. Am I right? Oh, okay, so the next one's here. The next one, I can just take a look here. I can just start. I can just stop in here. So if I stop in here, this green point will be what? It's 0 to what? To the 6, right? So if I want to flip back, so what here? So I can flip back here, it will be what? So this is R, okay, so I got it backward here. So here, so this is 6 and the 0. This is the angles, theta, right? Okay, so because the problem is that, hey, theta can be equal to 0, so that's fine. So that's why, so this one's here, now I flip back, so that's why I get a -6 and a 0. So this point can be represented by these 2 points. So someone will ask, you say, okay, why I cannot do like this? Go the whole 360. The problems here, if they don't have this restriction, yes, that's fine. But in here they say the angle has to be less than 2 pi. So that's why I'm using the angle theta here. Okay, so that's it for this lecture. So basically, we cover very basic the polar coordinates. How do you change it from the Cartesian to polar, polar to Cartesians here? Our next lecture, we're going to recognize the polar equations. Right, so what type of the polar equation will create a circle, and some polar equation will create like we call this rose petal, those things. Okay, that's it. And so hope you get a very good understanding how the polar coordinates was defined and its relation with the Cartesian coordinates here. All right, that's it. And then let's talk to you. Looking forward to talk to you for the second lecture. Let's talk about the polar equations here. All right, okay, bye. Have a good day. See you.